All right, this was sent into the channel for a review, and it's by a company I haven't ever heard of before, the ReeJoee, R-E-E-J-O-E-E. And it is a power supply with microamp current measurement capability. So when I first saw the product, I thought, oh, yeah, that could be very useful if you're building a battery-powered application. A lot of times, if you're trying to use something like this ReeJoee supply, it's really hard to look at microamps. So you have to use a separate meter if you wanted to monitor microamps. And this has a microamp meter built into it. So that's really great. Now, my first impression of it is it looks like it's constructed all right from the outside, but there's no markings of any type on it other than a bunch of stickers. There's a bunch of paper stickers that probably will get messed up quite quickly. So here's some instructions on how to use the knobs. Here's some stickers on the back on how to download some software. So they have three different models. This is the basic model. They have one model that comes with software, and over USB you can graph the current draw with time. And then they have another model that allows you to use this strictly as an microamp meter. But we'll be reviewing the standard one. Now, if you notice, there's no power connector on the back. So it comes with this wall wart. So it's a 26 volt? Yeah, 26 volt, 2 amp wall wart. And so we'll have to plug that in first. It goes in here. The power switch is in upside down. I always like to have the on in the up position and not in the down position, but okay. And then it has a big display. So yeah, so let's turn this thing on. I'll move things around a bit. All right, turn the power on. And it's got this nice big display, which I like. Let me change the exposure of the camera here. Oops, a little too far. Yeah, there we go, that'll be okay. So I like the display. It's got some volts and microamps, so that's what we're interested in. And then it's got some statistics on the bottom, so that's always useful. So let's, it comes with some clip leads here. So we can hook that up. There we go. So let's move this back a bit. And let's hook up a load. So I have a resistor box here. So we'll hook up a, I don't know. Let's hook up a 5,000 ohm resistor. That should be one milliamp, right? So put that up here. Oop. All right, so now it says press for on and off. Okay, so you can set the voltage here. So we'll set it to 5 volts. This is coarse and fine. Well, that's all right. So coarse and fine, 5 volts, and I've got 5,000 ohms. So it should be one milliamp. And then it says push on. And we get a red light, which I would imagine is on. And that's not 1 milliamp. So let's push it again. Push it again. Hold it down. Oh, there we go. Whoa. Oh, now it disappeared. Ah! Oh, there we go. It's 998 microamps. Okay, fine. Let's turn it off. All right. Let's turn it on. This isn't working right in my mind. You get a red light, that should mean that you're sourcing voltage, and I get nothing at all. If I press it, oh, and now it does something. So there's something definitely wrong with their user interface there. Oh, that's not good. So it is measuring correctly, I guess, though. But let's go into a microamp range. So I've changed it to 500 k ohms, and we're measuring, it should be 10 microamps. And it's really bouncing around too. Okay, let's go to 1 microamp. Let's go to 5 megohms. 5 megohms should be 1 microamp. And boy, is that bouncing around. So let's compare it with another meter. Let me move you guys a little bit. All right, well, there we go. We've got 1 microamp displayed here. So I have a second meter here in series. So we have perfect 1 microamp because I've got 5 megohms, and you can see that we're not measuring 1 microamp, and we're bouncing all around. So yeah, that's not good. That's not good at all. Let's go back to 10 microamps. We got 9.9, and we're just bouncing around over there. Now, the manual and their website, there's no spec sheet on this thing. There's no % accuracy. There's no offset. There's no temperature. There's no specs of any kind whatsoever. Buyer beware, yeah. This is just crazy. And I mean, it's supposed to be a microamp meter, so that's just stupid there. There is a 1 second average down here, but it doesn't match what it is. It's 9.9 microamps, and it's 9.73 over there. Now, it's got this weird instruction here. It says a long press 5 seconds to 0. So there's a zeroing function on this thing. So let's disconnect the leads, and we'll hold this down for 5 seconds. Let's turn it off first. I guess it's... You have to kind of have a long press to turn it. There we go. See, now it went on and off. This is awful. All right, so let's 1, 2, 3, 4, 5. Oh, and it did seem like it changed. So did we zero? I mean, zeroing to 0.2 microamps, that's pretty good, right? All right, so we'll say it's a good 0 now. And let's plug it back on. And now it's not measuring correctly. Here's the one over here. It's just not measuring correctly. So I say that's a fail. I say the user interface is a fail. There's no accuracy specs. That's a fail. There's the on-off button doesn't work. That's a fail. I don't know what the 0 does. I don't know if it's repeatable. I mean, how often do you need to zero it? If you come back tomorrow and you zero it, does all your measurements wrong again? I don't know. I don't know. So anyway, let's wow. Let's take this down to one microamp again, because it should operate fine at 1 microamp. This thing should be a microamp meter, right? We got 0.99 there. And here we're all over the map, and at best, we're with the averaging, we're measuring 0.8. So it's just wrong. And there seems to be, there's no service manual, there's no calibration routine. In fact, this is the instruction manual. This is all you get. It talks about the buttons, and then that's it. It's all it talks about is how to push the buttons. And in fact, that's written right on top of the machine. So that's the only instructions you get with this thing. All right, let's look inside. let's take a look inside. Screws off the top one here. Let's see. There we go. Well, there's quite a bit of circuitry inside. It's got a front panel. It's got 3 connectors to the front panel. Why would you need 3 connectors to the front panel? Wouldn't you just have 1 connector to the front panel? At least they're all different sizes, so I guess you can't mess them up. But yeah, the front panel has a display, rotary switches, a display and rotary switches, and that is it. So I don't know why you need so many connectors to the front panel. Yeah, there's no smarts, there's no ICs or anything on the front panel, it's all dumb. So it's got one big connector here that's marked RX, TX, switch 1, FA, C, and B, FA. So there's the quadrature encoders for fast and fine and coarse, and then the push button things for switch 1, switch 2, and then what would be the serial link? Why would you need a serial link? I don't know what that's all about. And then it's got a connector down here that's marked. Switch 1, 2, and 0. Okay, I don't know where that's going. And then it's got this, which is serial link, TX and RX. So that might be for the display. I don't know. Anyway, so you're bringing in 26 volts, and it looks like you bring it into a switcher, which is a little odd. I don't even know what the voltage range is on this thing. It's not marked anywhere. It's not in the instructions. I guess we can turn it on and see how many volts we get. But yeah, let's just take a look inside here. I'll just take a look at some ICs in here. Let's see here. We got a whole bunch of little ICs. What are these? Things are in the way. TLO81, TLO81, a TLO81, and a TLO81. We got 4 TLO81s. Wouldn't you get a TLO84? I guess these single jobbers have offset on them if you needed to tweak the offset, but there's no potentiometers anywhere. You could probably get away with just a quad package. I don't know. Let's see, what is this little funny guy over here? COS721SR. Oh, switch, what is that? C? Is that a I2C? Memory? What is this over here? L3888. Don't know what that is over there. 538. I think that's an LM538, another op amp. Lots of op amps in this thing. Wow. All right, we've got some FET switches in here. We've got 2 big FETs. Those are both the same. And then we've got another LM358. And we've got an LM358 there. I've got an LM358 there. Why don't you use a quad? Oh, well. We've got an LM358 up front. And we've got a LMC7660. Isn't that a DC to DC converter? LM7660. That's right up here at where you would measure the current. Maybe that's a fancy... No, I remember doing a video on that. That is a switched capacitor voltage inverter. So you bring in 5 volts, it generates minus 5 volts. So you have plus and minus voltages. So these op amps probably need plus and minus voltages, and that's where they're getting the minus voltage. That's what I would guess. And then this thing here probably is a switcher, so you've got 26 coming in. You don't want to just linearly drop that down to 12 volts or whatever it's required inside here. And so, yeah, that's what you got going on there. And then we got this, looks like another FET there. Yeah, it's a little bit strange. And we got another inductor over here, 330. I don't know, we got 100 here, 330 over there. I don't know, it's kind of odd. And here's another inductor over here. So, maybe it's just filtering? I don't know. I don't know. The switch, remember I told you the switch is upside down? Well, the switch here, watch this. Whoop. It's not held in there. It's just not, it's not held in there. So I'm going to turn it, can I just turn it upside down and pop it back in? There you go, now I'm happy. Now it's on up. The wires are going the wrong way. I should probably put some hot melt on there. Fix that. Okay. Yeah, I don't know. Like I said, there's a lot of circuitry in here. And so you might expect it to be better than what it's measuring. All right, let's see what kind of volts this thing has available to it. See that red light comes on, we get no voltage on the output. You gotta push it like a couple times and there we go. All right, so the voltage accuracy, 5 volts for 4.97. Okay, of course, let's ramp it up. How many volts can we get out of this thing? 12.2. Okay, 26 volts coming in, 12.2 coming out. And it shows 1 microamp. And I'm going to disconnect the front leads. And it says 1 microamp. Is this thing really drawing 1 microamp? Is my meter really drawing 1 microamp? I don't think so. It says so. Anyway, there you go. So how many amps can we get out of it? Let's turn this off. And let's go ahead and short the output and see what kind of amps we get. And it just turned off. All right, let's turn it back on. And, 11 micro, I saw 11 milliamps and then it crowbarred. So we need a load. Let me put in here. Here's a 50 ohm load. Let's just put a 50 ohms on it just for fun. 50 ohms, let's turn it back on. Turn it on, there we go. 11, and that crowbarred down. So it won't take a 50 ohm load. Let's turn down the voltage here. Turn it back down to 5 volts. And, oh, there we go, 100 milliamps. Oh, okay. So it's doing the 100 milliamp thing. So let's keep going up in voltage. 128, 140, 106, 170, 200 milliamps. Yep, 200. Oh, now it's okay? What? It wasn't okay before, remember? Let me disconnect it, and then I'll reconnect it. Yeah, my resistor is getting hot. I don't know what that was all about. Anywho, it's about a 200 amp, 200 milliamp supply, I guess. It's made for battery stuff, right? So normally you wouldn't go that high. Okay, well, limited in voltage, limited in current, limited in the amount of measurements it can make. It's just not accurate at all. And like I said, there's no specification at all. So I give this a complete fail. Can't recommend it at all. ReeJoee, R-E-E-J-O-E-E. There's no model number on the outside of the case, but there is a model number right here on the display. I couldn't figure out what that was for a very long time, but this is the model number. It's an 850L-0 or .0, 850L.0. So anyway, there you go. That's my review.